Okay, so today I present to you the holy grail of electronics books. All right, this is going to be a follow-up from my last video. You know, since I shared the Grubbs Basic Electronics over here, okay, that's a part of the Daytona State Engineering Program. I figured I just jump right into a book that I've been wanting to review for a while and just kind of give it all to you guys straight up. If we're talking about, remember I made some comments in the last video about this book being a little bit basic, but it is basic electronics, right? So it's a really good book for starters. One thing I didn't mention in the previous video is that this is all algebra based, which isn't a problem. Good way to start with electronics. But here I'm going to show you the Holy Grail, the most evergreen book I think I own and might ever have in electronics. Okay, and if you're not familiar with the term evergreen, means an evergreen book is one that'll basically last forever. It'll not be outdated. It's the information in it. It's like encyclopedic. Okay, this is like an encyclopedia for electronics. All right, I know art electronics is known in the kind of electronics pedagogy world or educational world as being the encyclopedia for electronics and the evergreen book for electronics, but I don't know. I've reviewed the book. I have a copy of it, a digital copy. I don't own a physical copy. I didn't learn electronics by art electronics, so maybe I'll have to do another video. Maybe I'll get a physical copy of it just to have on hand, because it's kind of like, you know, it's a major part of the lexicon. So if you're a collector of these kind of books, you'd want to have that. So I can't speak that much on it because I don't have my personal experience with it, but I have skimmed through it before on the digital copy, and I think it pales in comparison to what we have here, though this is a more updated book, so it has more current electronics in it. And it's not only that, but just the layout in it. I think the difference, you know, when I said that this book, the Grubbs book, is a little bit more basic, which it's, again, it's the introduction to electronics, it's basic electronics. What I mean by that, it doesn't have a lot of more complex details. And this book, I think what it does really well, this is the Practical Electronics for Inventors, okay, by Paul Schwartz and Simon Monk. Now, what this book does very well is it gives you the complexity, but it doesn't get overly complex, right? It's like, again, because it's intended for, it's practical, and it's for inventors. It's for people to make things, you know. So again, you know, part of me feels like, oh man, maybe I should not share this, you know, because like this is the book, man. This is the book, okay? Like if I had any kind of tricks up my sleeve, if I felt like, you know, I had an edge on anybody, as far as developing ideas or coming up with designs, it would be predicated on owning this book primarily, you know. But you know, I'm also a follower of the open source kind of movement in a certain way, and I have a sensibility that appeals to that. And I'll say, hey man, you know, might as well share it, you know. Someone else can, obviously it's not like I'm keeping any secrets from the world here. It's a book, it's been out for a while. This is the 4th edition. I believe this is the most updated edition, but you know, it's out and it's available. You know, again, I'm not keeping any secrets here, but what I'm saying again is just that, you know, if there's anything that's going to make you feel like you have a really good edge, that you're going to really maximize your potential as an electronics inventor or as a developer, this book will likely be the gateway. Again, because it has all the stuff that you might want to search on the internet and want to get a little deeper into. It's going to be in here, and it's going to be, there's a certain amount of complexity but also brevity that's really good in this book, okay? And that's what I like about it. Now we'll start and we'll go through it before I keep blabbing over here. So first page, symbol layout. It's got batteries, AC sources, some connections, switches, grounds, potentiometers, capacitors, inductors, diodes, some more on switches, transistors. It goes through all types of symbology for transistors, and I think this is partly why this book has an edge, is because it goes into very good detail with MOSFETs and FETs and all that, and maybe even some IGBT transistors. So yep, IGBT is in here. So insulated gate, polar transistor, bipolar transistor. So that's part of the reason why. But look, it even has tubes. It even has tubes. Now I don't know if there's that much literature in here about vacuum tubes, but it has the symbology here for vacuum tubes, which is awesome. You know, that's my world, paying some credence to the the pioneers of the electrical world. So photo transistors, all right, op amps. You got some gates in here. Just a great book. Okay, now the second page, we're going into resistors. So it's going to show the color coding of transistors or resistors again. Going to show you the tolerance table, capacitor markings. See, and all this is referential. See, it's much more, again, it's much more for practical use, right? Because this is referential. You could open this up and you could just try to figure out whatever you want to see, whatever you need to see is right here, okay? And that's part of what's nice about this. It's all laid out for practical use. Let's keep going here. And I didn't walk through this before this video and pick things out. I've got some tabbed out, you know, pages here that were of my interest, and I left that in there. And I'll probably just skim through and maybe go through some of those tabs. This is a larger book than you can see the kind of the thickness of it. It's a larger book than the basic electronics, but it's again it's like a reference book. It's not like a book that you'd read all the way through like you're trying to learn something even. It's more of a reference book. Now, who are these guys? Let's see about the authors. Okay, so Paul Schwartz is a systems operation manager who received his BS in physics, Bachelor's of Science in Physics from the University of Wisconsin. All right, now Dr. Simon Monk, bachelor's degree in cybernetics and computer science, PhD, software engineer. Okay, so these are the guys that you're talking about. Oh, he has some books on the Arduino and hacking and the Raspberry Pi. Okay, so here are some things I had highlighted: intro electronics theory, voltage. He goes through all this. You see, in the last book, I had a little complaint about it, that it went into insulators a little bit later, and this does it right in chapter 2. So it has a much better framework, I believe, for even if you're the first 2-3 chapters are really good introductions to electronics. So the intro, going into the theory, then going into insulators, and then wire gauges. Really good setup there. Then it goes on to AC, it goes on to capacitors, inductors, it talks about filters, then basic electronic components, batteries, switches, relays, transformers, inductors. Now we have transformers in here, which we didn't have in the other book. Now semiconductors. What are semiconductors? It goes into diodes, transistors, thyristors, integrated circuits, optoelectronics. So that's going to be all your photodiodes and all that, sensors. You know, again, he's going through basically all the kind of components you could ever, because again, it's for inventors. So anything that you want to invent, so he's going to go through all these sensors. So a temperature sensor, proximity and touch, movement and force, chemical, light, radiation, magnetism, sound sensors, okay, constructing circuits, multimeters, oscilloscopes, operational amplifiers. And like I said, really good detail on the operational amplifiers. Filters, he's going to go into really good detail on filters. Digital electronics, Look, I mean, chapter 12, digital electronics, is over 100 pages. It's like 120 pages almost of just digital electronics. So again, very deep stuff here. Motors, audio electronics, power distribution in home, error analysis. And that's where I believe he gets into some calculus. So there is some calculus here, and useful facts and formulas. Okay. So in the useful facts and formulas, he goes through Greek alphabet, powers, linear functions, quadratic functions, exponents, logarithms, trigonometry, complex numbers, differential calculus, and integral calculus. So basically, all kind of the basic kind of mathematics are involved in electronics. So very good, very good. So here we have the introduction, and maybe if I can just skim a couple pages. Here he talks about the electron. He's got the equation for the electron, for the I think he's calculating the current, how many electrons are in 1 amp of electrical current. Then he talks about conventional currents. And this isn't really a math heavy book. It's really there for explanation, I believe. And that's what it's really good for. It's really good at explaining, and it has good illustrations. And it's just kind of everything you want in a reference book. So here we go into, I think, conductance, and he's talking about like the electron path in conductors. Here's a really cool table I like a lot. Like, this is the kind of cool stuff that this thing has in here. I mean, so you have a table here of conductors, okay? And they're showing you here temperature, velocity, electron density, work function. So we have all the properties of these various metals here that we might use as conductors. Very cool. Resistance and conductivity. I mean, if you want to have really good working knowledge and some physics, some like good science and physics involved, then this is it. I mean, you could start off electronics on this, and I would recommend it. I mean, look at this. He's got another table. He's got another table, conductance of various materials. So this one has tungsten on it, and platinum, brass, the silicone, gallium, sulfur, Teflon as insulators. So he has some insulators. He has some semiconductor materials in here, and you can see from the conductivity, you can compare them. So the conductivity of aluminum as compared to the conductivity of Teflon. Teflon is 10 to the negative 14. Conductivity of aluminum is 3.55 times 10 to the 7th. Temperature coefficients, resistivity. I mean, all just awesome stuff. Let's go to one of these pages I had here marked here. What was I looking at? Thermal resistance. He's got a table for thermal resistance of items. Common ground. So now he's looking at ground showing you about ground loops. That's another thing we didn't really talk about in the basic electronics video. So let's spend a little bit of time looking at this, because again, like I said, we didn't really go through this too much. The other book I don't believe had any reference to ground. So grounding is a really big thing, especially if you're going to make your own circuits, especially like what I used to do with is audio electronics, and grounding, improper grounding can cause a lot of noise, and you don't want that. So that's one of the biggest battles. You could have a great circuit, a great idea, but if you don't ground it properly, or I can say properly, but almost every situation is different, and that's kind of where electronics gets interesting, because you see a lot of the physics with grounding, because sometimes having a ground too close to a certain thing could cause noise, right? So things that you wouldn't expect, like ground can be a very elusive topic. You know, it's not just a safety thing. There's certain phenomenon that can be caused by grounding things in a certain way. Grounding certain things in a certain way can even cause oscillation. You know, so you might have an amplifier that's oscillating and you don't know why, and it might be a grounding issue. A ground being too close to something, again, that might cause that. So we've got a bunch of different diagrams on improper grounding and proper grounding, how things should be done, which is really useful. Again, different ground symbols, very important stuff. If you're new to electronics, I would not gloss over this. I would study this very, very much. Some stuff on resistors, the voltage divider design, very practical use there. Let's keep going. I'm just going to keep flipping some more pages here. He's getting into capacitors. You see there is some integral calculus here with respect to capacitors, the energy in a capacitor. So he has these more as examples. He's not really expecting us to do the integral calculus here or anything like that. He's just showing formulas essentially. And I think he even gives you simpler versions of the same equation. Discharging a capacitor, again, very useful. Sometimes you could have a circuit that has high voltage in a capacitor and you want to discharge it, so because you don't want it to have high voltage in it all the time, because someone might work on it, or you might work on it, and you don't want to open it up and have to discharge the capacitor all the time. Again, very practical stuff here. Now we're getting into magnetism. Again, I can't go every page because it's just there's so much Faraday's law, there's so much material in here that it'll take all day, but a good combination of physics and electronics and practical use. I mean, you'll be a pretty good master if you look at this stuff. I mean, and it's not dumbed down. I guess it's what I like about it too. It's not dumbed down, but it's very useful. Okay. Then we're getting into ferrite, the permeability of ferrite. Ferrite is used to suspend radio frequencies. Iron core. So we're getting into some inductors. Okay. Studying a little about the Henry. I'm going to flip a couple pages here. This is still considered basic, pretty much, right? This is just talking about networks and circuits, you know, basic networks. We're on page 200. If you're still on basic networks, we're getting a little bit into frequencies. Look at this. Full wave rectification. Spice, he even goes into Spice now. So we're talking about simulators. So Spice is like CAD for electronics designers. So he's showing you an example there of Spice, and maybe someday I'll do some more Spice tutorials. Something I haven't spent that much time on, but haven't spent that many videos on. I spent a lot of time on Spice, just not making videos, and it might be worth it. So you got a little matrix here. Basic components. Now we're getting into batteries and wires. This is what I mean, just great reference. I mean, how could you ever get tired of this? Anything you want to know is probably in here. Different types of capacitors, so polyester film, polypropylene, silver mica, ceramic capacitors, titanium, oil-filled capacitors. Now we get into full wave rectification. Talking about ripple, how to get ripple out of your DC. Now we're talking about high and low pass filters. Current limiters. Shortwave receiver, so a couple of block schematics, shortwave receiver, an amplifier, an oscillator transmitter. Very cool stuff, and it kind of breaks down again the basics and gives you good building blocks for how these things work. Transformer cores, variac. Man, it just goes on in this thing. Diodes, now we're talking. Look, we've got a full list of diodes, most popular diodes here, right? Because this is another thing you want to get familiar with. You know, you're getting into electronics. You got to kind of know what's commonly used, right? Kind of the most common items. Some of this is, of course, probably changed now because we're surface mount devices. I know a lot of parts that I used to use when I grew up, they're now also obsolete, but always good to know. Voltage quadrupler, voltage tripler, AC or AM detector. Now we're getting into some transistors. Looks like a very good layout. Gets you all the equations at different points of the transistor here. Transistor has a switch. Oh, transistor has an amplifier. Now this I talked about at length pretty good the other day in the basic electronics, as you can see how much more detail he goes into here. He's talking about the common emitter, and he gives you all the, he's got block frequency or block formulas pointing at the area in which that formula relates to. Very helpful. He's got explanations all around it. And he shows the common, he shows this is a common collector amplifier. Common collector amplifiers, so I'd suppose, so it looks like, oh, he has common collector first. That's unusual. First he goes into current biasing, and then goes into the emitter follower. Oh, just very good stuff. I mean, this is where you really dial things down. Now we're at the common emitter follower. So then he does the emitter amplifier and then the common emitter. Very good stuff. Oh, now we're getting to Darlington pairs. See, that's nothing. See, we didn't talk about that. Voltage regulators. Didn't talk about that in the other book. Very useful stuff. Relay drivers. Let's see if I can zoom out a little bit here. That's a relay driver right there. Complementary amplifiers. Complementary symmetry. So this is where usually like in a pull push amplifier, you saw that kind of configuration in the block diagram of the integrated circuit that I showed you in the previous book. Logic gates, he's showing you here how to make, there's some multi-vibrators or flip-flops, sometimes we call them. So there's multi-vibrator circuits. He's showing you how to make gates out of transistors instead of just the digital way. Then he goes into the same kind of things, but with JFET transistors. Very useful stuff. Audio mixer. Now we're getting into MOSFETs. Look at all the information on MOSFETs. I mean, guys, like I said, you kind of have an idea now why I was talking about this book. I mean, you'll be able to create anything you want, answer all the questions you need answered, and come up with some really great stuff with this book. And I've had this for years, and I still haven't scratched the surface, really. You know, it's just, again, it's a reference book. It's really a reference book. Let's keep going. Optical, so here we're going into LEDs, we're going into like photodiode stuff, lasers, it looks like a little bit. Light activated relay, you ever wondered how that is done? There you go. Sorry if I'm going a little bit fast, it's just there's a lot in here and I want to get there. And like I said, this book is just too large. Also, AC isolation transformer, very cool to understand that. There's just too much in here. Look, it even goes into DIY workbench, how to make a workbench for yourself. I mean, this is the real deal, serious. You know, operational amplifiers. We talked a little bit about them the other day. A peak detector, that's always a staple in operational amplifiers. Okay. Timing. Some power inversion. Okay, this is pretty cool. Okay, a dual. Look at this. Let's see if I can get that in the shot there. Okay, so a dual polarity power supply, 12 volt. Like I said, I don't know that any of these regulators are used anymore. This is much how, like when I grew up, this is the kind of topology I was used to, kind of topology I would still do or use. Today, this is really going to be done with pulse width modulation. So this is kind of outdated. Like again, I don't know that any of these regulators are actually still on the market. Hopefully they are, though. It's kind of nostalgic at this point. Okay, what are we getting into now? So we're getting into digital. He's got some coding, 7-bit code. He's got a coding table with all the ones and zeros, a hexadecimal, some common chips, some common and NOR and NAND gate chips. Some more on logic gates. Looks like some truth tables. Some CMOS stuff. Some more with gates. Flash memory, RAM, microcontrollers, very popular today. Arduino, a little bit on some code. A simple DAC, a digital to analog converter. Programming, step motors, audio electronics, preamplifiers. That's what I loved. I used to love designing preamplifiers. We got a couple preamplifier blocks here for microphones. Crossover networks, modular electronics, and the useful tables. All right, so we go through the alphabet, the Greek alphabet. It goes through some trigonometry. It goes through some exponential functions. It goes through some integral calculus, some derivatives. All good stuff, man. So again, if you want basically the best reference book out there for electronics, now if I find something else, then I'll eat those words. But as far as I know, this is the real deal. This is the best. So your reference book for electronics, Practical Electronics for Inventors. Let me know if you have any more questions. There were a number of you that reached out in the last video. I appreciate the engagement, and if you have any more questions or want to know anything else, let me know and we can further the discussion. We can keep it going. If you're studying electronics, or if you're wanting to study electronics and you want some more information about anything, or you want to discuss some topics or a book, or if there's some area that I could go into more detail and, you know, coming up with designs or schematic writing, anything of that sort, let me know. But in the meantime, see if you can get yourself a copy and enjoy it.